Okay, you guys pretty much understand how this works now. So we're looking at our theorem page here, and we're going to try to finish up the last couple. So in case we didn't get names and numbers, theorem 7 and 8. 8 I call the congruent plus supplementary equals right theorem. Kind of an awkward name, but we're kind of summarizing what it is. And remember, a theorem is just a shortcut, and we need to know what it says anyways, because we're referencing that statement when we're using it. So it kind of reminds me, if I say it that way, if two angles are congruent and supplementary, then they're right. That one does have a reference in your book, and that's 2.7-6. Okay, following up the right angles theorem, which was 2.7-5. And then let's take a look at the last two. So, if two lines are perpendicular, then any two adjacent angles are, and we want to try to make a conclusion that's always true. So, you know how I like to think through these. I like to kind of do a little bit of drawing and sort of picture it out. Two lines are perpendicular. So, I need two lines to talk about. I'm allowed to number or letter them if that helps me. So, I'm going to call my lines L and M, just for the sake of having two things to talk about. And L is perpendicular to M. So let's just give that a go. And adjacent angles is what I'm talking about. So I'm going to find two adjacent angles just to talk about here. An example of adjacent angles would be something like angles 1 and 2. And what do you think? Yeah, I like that idea. So I heard somebody just say that any two adjacent angles are supplementary. And my question is that based on the fact that the lines are perpendicular? So let's just draw two lines intersecting. They could look like this if they're not perpendicular. And you see that in that case, angles 1 and 2 would still be supplementary. So I'd say that's not a good conclusion as far as the most specific based on the lines being perpendicular. That's really just because I have a linear pair whenever I have two lines intersecting. So let's go for a little bit more specific. And yes, I heard you also. I heard somebody say that they are congruent to each other. Two adjacent angles are congruent. And I think that's going to be a really good conclusion for us. I know that came up when we were doing this one, number 7. We had a couple ideas here as well. And congruency is going to be a helpful conclusion in our future. So I have a little bit better perspective than you guys do of what's going to help us and what's going to give us some shortcuts and save us some time down the road. So then let's go ahead and make a specific conclusion for ourselves. Angle 1 is congruent to angle 2 in this scenario is a conclusion that we can make. So that's going to be your first proof task for today. I am going to give that one a name. Usually I don't like to name it until we actually prove it, but let's go ahead and do that since we have this paper out and we're all together here. So I don't like to call this just the perpendicular theorem because perpendicularity is going to show up more than once in a theorem. So I like to call this the perpendicular adjacent angles theorem. And that's just a little bit more specific. Theorem 3.4-3 as a textbook reference. And then you're already reading the next one, which is perfect. So I'll give you a minute to think. In fact, you can pause the video. If two lines intersect and form congruent adjacent angles, then the lines are. Okay, so if two lines intersect and form congruent adjacent angles. Okay, so I've got intersecting lines again. And I'm noticing adjacent angles are congruent. Interesting, because that's the conclusion from the previous one. So angles 1 and 2 or adjacent angles, I know that those are congruent to each other. So if I know that angle 1 is congruent to angle 2, and I guess the picture kind of goes with this one too. I know that angle 1 and angle 2 are a linear pair there, formed by intersecting lines. Then what conclusion can I make? And I'm just noticing, since these are right next to each other, your conclusion from that one is your hypothesis here. Is it possible that this one's just the converse? In other words, do I know that L is perpendicular to M? By knowing angle 1 and angle 2 are congruent, take a look at that picture. Does that guarantee the lines have to be perpendicular? I'm pretty convinced that that's going to be true. So I hope you're convinced also. And maybe think about the opposite. If angle 1's not congruent to angle 2, well, then those lines aren't necessarily perpendicular to each other. But by making that true, we do know the lines are perpendicular to each other. Okay, so let's jot that conclusion down, that they are going to be perpendicular to each other. And since this is a converse, let's save ourselves the trouble of renaming it as a different thing, and let's call it a converse. So I'm going to call this converse of perpendicular adjacent angle theorem. That's still a lot. And that would be 3.4-4. And now you have 2 proof tasks. So you're going to spend some time working on those tasks and see what you can use. Remember, you can use prior theorems that we've proven. Now that we've started proving some theorems, you can use that in addition to definitions, postulates, and properties to complete your proof. So let's see what you can do putting those together. Feel free to collaborate with your peers. Always a good idea to put more than one brain together. And just a friendly reminder that we're going to turn the if becomes, when we're doing a proof, the if becomes the given, and the then becomes the proof. And you guys are doing a nice job with this, so I think you are well prepared for that. Good luck. Have some fun. Happy proving.